slideshow, and we'll go through this agenda. We'll go through what is basically system design, how it plays very crucial role in our day-to-day life. Then we'll go through requirement gathering phase. What are requirement gathering? What is the functional requirement? What are non-functional requirements? How they are important, and how our system design varies for, let's say, 100 people versus, let's say, 1 million people versus planet scale, which is 8 billion. So our designs choices will vary based on how we are going to consider our non-functional requirements. Then we have API design, where we'll discuss what would be major external facing APIs that will be part of our system, and through which external entities will interact with backends resources. Then we'll go through actual component design and deep dive on each of the section. I hope that sounds funny to you. So to start with, system design, we want to know what basically system design is. Basically first principle of any software development. Any system that you see in the real world has built on top of the system's components, such as databases, such as API gateway, load balancer, servers running, and multiple cloud resources like message queues and rate limiter, etc. So based on these components, we try to design our system as reliable and as scalable as possible, so that end user will not be facing any issues with respect to his experience with the overall design. So in this reference, we consider components as databases that might be SQL based or NoSQL based, then caching layer, then there are message queues, there will be network communication come into picture, whether we want to rely on HTTP requests, TCP, UDP connections, or web sockets. Then there would be workers, usually known as cloud functions, example AWS Lambda or step functions. And then there will be microservice based architecture, where we want to divide the functionality of each service independently, so that they can grow scale independently as possible. Example of this would be simple rate limiting thing, right? So let's say we have a rate limiter for a plain backend of Amazon website, and we have rate limiter for the some of the internal services hosted in Amazon. Obviously, traffic coming to external services definitely more than whatever traffic comes to the internal services. Based on this, we want to make sure each of these components, each of these services grow and can be scaled in as independently as possible, without we trying to take any beefy server and host everything into single machine. So this is how usually system design is around. We want to take a functional requirements, non-functional requirements. We try to design this aspect from it, how each component would look like, fit in its place, so that at the end we would be able to get workable MVP, and hence that design can be scalable enough to host as many users as possible. Let me take a pause here and go through questions if we have any here. Okay, I don't see any questions. I think we can directly jump into requirement gathering. Anyone has any questions on this? Cool. Awesome. So let's get into fun stuff actually. Here, we want to design the Tinder. So for Tinder, let's take a step back and decide, if you are the founder of Tinder, or if you want to create a new dating based application which is associated with the location. Okay, so you want to have people actually meet and date, or make friends for this. So in that case, what kind of requirements would you consider to have in our application to begin with? You can use chat, or if you want, you can unmute yourself and share your thoughts. Anyone? Okay, descent profiles, words, category by age, location, new profile creation, sending connection and chatting. Nice one. matching algorithm, user interest, block users. Yeah, all these are actually really important requirements of the Tinder, right? So whenever we consider any dating application, I hope this is visible. Let me increase my font here. So whenever we consider dating application, first thing which we would like to have is good recommendation. This good recommendation is really fluffy term in a way. We want to specify what do you mean by good recommendation. Recommendation by age, recommendation by gender he or she might be interested in, by location, avoiding bot usage so that there will be as much real accounts as possible. Then what else we have? We want to have a recommendation on top of hobbies, as correctly mentioned. Okay, based on user preference, matching algorithm, user interest, profile creation is good thing. We want to obviously have the profile creation, otherwise to whom we will recommend to. There will be login, yes. Login, authentication, authorization will be part of this. Anything else? Yeah, authentication, username based on user preference, matching algorithm. Yep. Sending connections is good thing. Swipes is, I guess that is what I'm taking. Som Surya, right? Swipes, I like versus dislike, right? Or we can say left versus right swipe. Anything else? Super like, yeah. Super like is something, I guess, would you consider that as a MVP requirement? No, I guess, right? To begin with, or if you want to have a presentation in front of, you know, funding members or for the investors, I think we can avoid super like as a MVP, and we can make sure our design is scalable enough so that we can extend it to have this super like and all the remaining things. Similar accounts when you like, right? That is, I guess, will be covered as a part of recommendation. Messaging system, right? Messaging is really important thing, okay? Messaging is something we want to see if it is MVP, or we can take it as a P1 requirement. I would say it is MVP because based on like, we would immediately like those users to have communication without anyone leaving the application, and they would have the as much interaction on application itself than they going somewhere else like WhatsApp or Telegram or even messaging for the communication. Sticking users to most of the time on the application is something which we definitely want to have. Awesome. Notification, profile upgrade. Yeah, I think swipes in the profile creation, I would just add update because this is really important. And then I would again consider this as preference update as well. So by preference update, I mean, in which profile now I am interested in. Now let's say today I am seeing some of the recommendations, and I figured out that hey, this is something is not working for me, or either I change my location. So let's say tonight I am in Bangalore, and day after tomorrow I join Pune. Okay, so I would like to see recommendations from Pune, right? It's not like I would like to still getting recommendation from Bangalore, and they are going to have no use. So one important thing which we missed here is recommendation based out of location. So this location is very sensitive. So location, we want to see either 25-kilometer radius, or to be on safer side, we can consider 50 kilometers of radius. Till this point we can provide the recommendation to end users, and after that we can consider, hey, this is something user is not going to definitely visit the other user, or they are not going to date offline world. So let's just not show those recommendations. Awesome. Live location, no, right? Live location, we definitely don't want to haunt users with live locations. Okay, cool. So yeah, this is something which is basically functional requirement. At this point, instead of going to slides, this is really interactive discussion here. So in going to slides, we are going to see, it is there will be MVP requirements, that is minimal viable product, through which we can just create the application and make it scalable enough so that if user scale starts growing, similar to the threads application recently released by Facebook, right? So they got such a sudden spike, their user base hit in over 50 millions, that too in very short time. So that's the kind of design they had, so that they were able to provide the user experience as smooth as possible. I know there were some glitches, but yeah, they would have definitely considered this thing, that we want to keep user experience as smooth as possible. So recommendation based dating application is what we're looking for. There will be user profile management. This includes profile creation, search preference, how we are looking to, with respect to location, where the specific user is located, etc. Then we have profile matching, which is nothing but recommendation, right? So let's say XYZ is a person with age 30, and his dating preference, because he is male and he has dating preference in women, will try to see and find, in 50 kilometers of range, what are the suitable requirements for his or her account, based on hobbies, based on his preference and all those stuff. So this is profile matching and recommendation. Then we have location sensitivity for this application, given we want to have users meet offline and you know date basically. So that is there. And then notification is something when, let's say, I right swipe someone, after some time, to person to whom I right swiped, she also right swiped, and based on that we get a match. So in order to know, hey, there is a match on the application, I would like to see notification on my on my mobile, or yeah, we are going to consider mobile only. It does not make sense to have Tinder website as a website basically. It is better to have mobile application to begin with. So then comes very interesting thing, something known as, okay, so is it fine? Shall we freeze this as a minimal viable product requirements? There are five of them. Five of them are all good, all look good. Can we freeze those? Yeah, cool, awesome. Now comes the, okay, so till this point I hope there are no doubts. We'll go to the doubt first pause once we discuss the non-functional requirements. So NF are usually known as non-functional requirements. So what are these? Basically, if we see dating application, whatever first five requirements we have combined, they are something which are associated with product. So if you are working in any company and joined as a fresher, or joined as external hire, SD1, SD2, SD3, there are some dedicated people, let's say product managers, who will come to you and say, hey, this is new feature, and we want to create our company wants to jump into this dating application source entirely, and they would come to you and say, these are the top five requirements we want to incorporate with, and this is how you will get the actual end user requirements part. Now non-functional requirements is something engineering specific. Here you as an engineer, you as a software developer, need to take care of these things, so that whatever functional requirements are decided with and frozen with you end user, these product managers, sometimes CXO also comes into pictures. Let's say CEO has special interest in this application, he or she might join into this kind of discussion, saying, hey, these are the requirements we must have in our initial product. So functional requirements are fine, you will freeze them, but non-functional requirements is something you as an engineer need to take care of with discussion with with your senior SD, with your SDMs, with your other tech architects, in order to make sure that whatever app experience, whatever backend experience, front end experience we are going to provide to end user, it is as smooth as possible, and we have always correctness in the application. So taking a step back here, let's say instead of this dating application we were creating a banking, okay, we want to create a banking application. In that case, most important thing comes as functional correctness. Functional correctness is something, let's say my account balance is 100 rupees at this moment, unless someone sends me amount or I send some amount to other account, my balance should remain 100 rupees. There is no scope of any issue in that aspect. Application correctness is something that needs to be there, and this application correctness varies from application to application. For banking app, it is something where consistency of data with respect to your money movement is very important. Whereas for applications like Tinder, applications like Facebook, applications like Twitter, they do not worry much about the actual profile. Example, let's say I created a new account with this Tinder application we are going to create, right? So let's say I created an account. It does not matter, for 1 hour, for first 2 3 hours my account is not getting shown into feed of other users. That's still fine. After 3 4 hours, once some processing is done, once my account is verified, this is not a bot account, this is something genuine account with actual user running behind it, they would approve, and then my account will start seeing into other people's recommendation. That's fine. It is not like the moment I hit the create profile button, my account started seeing into other people's feed. That is not actual requirement for applications like Tinder. Same goes for the Twitter, same goes for the Facebook. If I post something, it is not genuine requirement that my post started looking into other people's feed. Some gap in terms of seconds, in terms of minutes, in terms of hours is fine. This definition of time varies from application to application. Some application might want to have more processing before showing up whatever new resource you have created. Some might just have to just push the data and update to the database. So this time varies based on application to application, but this is something that we want to look into. We want to make sure that application is correct, or website, backend resources, front end applications are as correct as possible with respect to context of the application. Okay, so that's what we try to cover up in non-functional requirements. So in non-functional requirements, have you heard about the cap theorem?
Consistency.
Sorry.
Consistency.
Yeah, consistency. Let me write it here. Not in front of requirements. Let's scroll down a bit and add here cap. Okay, so in cap theorem, C stands for consistency, A stands for
Atomicity.
atomicity. Are you sure?
No, I'm not sure. But,
Okay, anyone else? Okay, availability, Nikhil is right.
Availability.
Yeah, right.
Availability.
Okay, Pankaj has already written to everyone. Okay, awesome. A stands for availability and P stands for
Partition tolerance.
Partition tolerance.
awesome. Partition tolerance. May I know what we mean by consistency? Okay, instead of me being asking you, I'll tell you what each of these terms mean, and then we'll discuss whether our application needs consistency, availability, partition tolerance, and how would they vary our overall design. So consistency, as I was explaining previously, implies the, in terms of banking application, correctness of my account balance, correctness of my money movement. So consistency is something at any instance of time, if I take a look at the value in my database for a specific resource or for specific row and column, they should be same across the application. Okay, so if I say I check my bank account balance in mobile using Google Pay, UPI, and then at the same time I check that balance using PhonePay's uh, bank balance feature or Paytm's bank balance feature. I should see same value across the at all time across the applications. It does not matter through which I am accessing the resource, it should be the same. So that's how consistency would imply. Let's say someone transfers me 10 rupees and at that moment I try to see, what's the balance look like. It should say 110 across the applications. That should be that should be consistent only. It does not give us the opportunity to have a mistake in this value. Similarly, availability. In terms of availability, what we want to see, we want to see our application up and running 99.49% of time. So whenever your application is running, it should take a request. It does not matter whether it gives correct answer or not in terms of availability as a correct solution. So what is expectation from end user is you should be able to take the request from end user and provide some output. You should not throw 4xx or 5xx error. Basically, you should be able to take the query from end user and should be able to provide some of the any answer. That answer need not to be consistent enough. That answer need not to be correct all the time. This is how just availability in terms of cap theorem looks like. And partition tolerance is something where we want to say, hey, there are multiple resources in the distributed architecture for this system. They should work as expected, whether there is some partition tolerance. By partition tolerance, let's say there is communication wire between server A and server B, and someone just shut down server A or just cut the wire between server A and server B. It should not affect our application and it should behave as it was behaving earlier. It does not matter for network partition tolerance between the resources in backend. This is how partition tolerance is usually defined. And cap theorem implies our system will always have two of the three properties. So system can be either consistent and available, system can be either consistent and partition tolerant, and system can either be available and partition tolerance. Three of these things are difficult to maintain, although there are some recent innovations. By recent innovation means, there is Cockroach Lab coming up with the database trying to serve CAP as well. Then there is Google Spanner database trying to beat the cap theorem and providing all three of the properties at the same time. But in traditional system design or in traditional components that we see, we either see CA systems, we either see AP system, or we either see CP system. This is the combination we can see across the board for the according to cap theorem. So in this case, what we want to see, the Tinder applications. In Tinder application, according to you, let's take a specific service, because cap theorem is something not related to entire application or entire backend resource. Cap theorem is about how each of the service will behave like. So let's say there is a let's ignore all the Tinder application and let's just focus on the recommendation aspect. Now if we see recommendation service as an independent component, how would we like it to behave? Would we like it to behave like consistent and available, consistent and partition tolerant, or available and partition tolerant? Somsir is saying CA, Ritesh saying AP. Okay, Ayush saying AP. When we're talking about consistency, is it restricted to database only? Vedant, it is not restricted to database directly. Usually cap theorem has been defined for the services, not the database. But given services obviously communicating with database, at the end it matters what is the property followed by database is inherited by the service itself. So They are in a way superset of each other. Okay, we are getting AP and CA as an answer. Let me write AP versus CA for recommendation. Okay, people saying availability and partition tolerance, and people saying consistency and partition tolerance. Can someone from CA answer loop, can someone explain why would it be, like, why do you think it will be consistent and it will be available for recommendation? Anyone
Uh,
can unmute.
Hi, Som Surya here.
Hey, hi.
Hi. So for my analysis, I thought that it would be consistent and available because the data which it is working on, that should be partition tolerant. And the
Right.
main thing is this engine actually would process the data from a database, which it fetches from the database, which is based on the user profile and other things. And this should be fast enough for the persons to get the recommendation, as well as this should be having a very what to say, fixed answer, or the deviation should be less, so it should be consistent.
Okay, I got your point. So what you are saying is, let's say if I started seeing recommendation for my profile, they needs to be consistent in a way that these profiles are genuinely there and they have consistent information. In a way, let's say person has added swimming as his or her hobby, you should be seeing swimming as a hobby for you as well. When they immediately remove that swimming as a hobby, you should see the change in the value and swimming should be removed from the hobby section. Is that what you meant?
I thought the recommendation would be sort of matching recommendation, so the recommendation engine would be much more
No,
clear.
the match, let's ignore the matching fact. Let's focus on the recommendation itself. Recommendation as a feed, basically.
Okay, then I would change my answer to AP.
Okay. Would you be happy to explain that? Why would you consider it as
Because
a
in
AP?
this case, the consistency of, like you gave the example, like if I change in swimming, immediately everybody needs to know that I love swimming and or dislike swimming. That thing. It is not such a consistent data, such as a banking figure or a bank balance, something like that.
Right.
So it can be traded off with that of partition tolerance.
Right. Pankaj, Revan, let me know if I'm taking your pronunciation correctly. Most of the folks have answered correctly. Manish has given a very good explanation as well. Manish Kumar, shout out to you. Consistency should not matter. It can give slight different results for same request at different time. Yeah, that is exactly how we are trying to consider the correctness of a system. It does not matter if I get some different recommendations during some time. Let's say I remove my profile. Okay, let's take an extreme example in terms of recommendation. What extreme would it happen? Let's say for I removed my profile from the Tinder. At that moment, if I expect it to be consistent across, whatever recommendation people are seeing during that moment, they should see blur screen that time. They should not see my profile in the recommendation immediately. What's the worst gonna happen if they still see my profile for 2-3 minutes, 4 minutes, or few seconds as well? It does not matter, right? Because I deleted my profile. With respect to GDPR compliance as well, it gives us 6 months of time. So if anyone aware of GDPR, please write that down. I'll explain it further as well, but if someone knows about GDPR, I would love to hear your thoughts on this as well. So even GDPR enforces or gives us some time to make sure every user's data has been removed. It does not matter if we want to remove that immediately or not. Yeah, Manish, you're right again. European law on data privacy. So it asks us to, it basically enforces these internet companies that, hey, some user asks to remove the remove the data of specific user, you will need to remove this data during some duration. So say this is on date D, I removed my application. Till some time you have the permission to remove this data. There is some window, and after that window, if someone checks on your backend system across a database, across services, you should not see data for that user. It does not ask us to remove immediately, so it gives us some cushion with respect to consistency for the feed for our application. So this is how, for recommendation service, I would consider it as AP service, and I would remove the CA part. Okay, I hope cap theorem is clear to all of you. Okay,
Yes.
awesome. So yeah, let's come back to the NFR requirements. Now, non-functional requirements, something which we would like to see in our Tinder application. Something latency we have to worry about. We'd like to see minimal latency, as minimal latency as possible, or near real-time experience is what we strive for. Anyone wants to add any other non-functional requirement for recommendation? Recommendation service will be AP. Our messaging, whatever messaging we are going to, whatever swipes we are going to provide, do they need to be AP or CP? Let's say I do left swipe, right swipe. Does it immediately need to reflect in the system that this person has done right swipe or left swipe, or is it fine if the message reach out to other person, the notification reach out to other person, say 1 minute later or 2 minutes later? Does it need to be AP or does it need to be CP for the swipes? Okay, AP, we are getting same answer, AP, awesome. So swipes need to be AP. What else? Profile creation. Let's say I created the profile. Okay, does it immediately needs to look to me as the profile is created and you should start seeing those profiles in the recommendation? No, it's fine if it takes around a few seconds to update the profile of mine and push to recommendation of other services as well. So profile is something AP. So overall, whatever systems we are going to consider, they are going to be part of AP. Then I want to focus more on the location aspect. Okay, location is something which we are focusing on our application since very beginning. Now let's say I'm interested in profiles within 50-kilometer radius from my location. Okay, so let's say at this point I am at Sarjapur, and from Sarjapur or from Belendur, I want to seek profile that are within 50 kilometers. Would it matter if our application will show profiles within 51 kilometers or 49 kilometers? Would it matter? No. Right? So location approximation is fine. So by approximation, whenever we are dealing with location, okay, our earth is sphere, and whenever we want to find distance between point A and point B, it is never going to be correct unless you fly through aeroplane or helicopter. Why? Because we're trying to find distance between 2 points on a plane, on a 2D of a 3D surface. It is never going to be accurate for any of the systems. So whenever we consider a location, we try to project spherical earth on 2D surface. Let me go back to one of the slides which we have. So this is earth as a sphere, okay, on the right, this side. So the earth as a sphere, we try to project as a 2D object. On that 2D object, we try to find distance between point A and point B. So this is how location is always going to be approximate for our system. Okay. What else? Design should be highly available and scalable, which were already considered. User should have near real-time experience during swipe. Thus, downloading images and profile should have minimal latency. This is expected. HTTP interface, and I added question mark. I want to know from you, are we aware about HTTP request? HTTP.
It is one of the protocols used in internet communication to transfer packets between a server and a client.
Okay, awesome. Right. So from that definition, if we go little deeper and consider creation of TCP record, okay, for TCP record there will be always three-way handshake. If client first reach out to server saying that, hey, I am creating a communication, server sends acknowledge back, and then client sends, received acknowledgement, and then communication starts from there. So there is always three-way handshake between client and server for HTTP TCP request. Now here is a question, and it is open-ended question. No one knows correct answer. There is no correct or incorrect answer for this. So whenever we are doing swipe on the Tinder, there is left swipe and there is right swipe. The swiping, for each swipe, backend needs to know for this user profile, what is my preference? Is it right swipe or is it left swipe? Now for these frequent calls, how would we suggest creating a profile so that there is no network, let's say there is efficient network bandwidth usage? So network communication is going to be based out of HTTP. How would we want to make sure the network bandwidth, whatever we are utilizing, is as accurate as possible? And there is no right or wrong answer. Anyone has any context around this?
My guess would be, if I remember correctly, UDP uses less bandwidth. So UDP would be fine because in this case, we don't need, like you said, like an immediate, we don't need a secure connection or the security features that TCP would offer in this case. All of the current results that the user is seeing, the current stack would already have been loaded locally. So we could use UDP and broadcast it to the backend. And later on in future searches, it will not recommend that particular profile again.
Yeah. Was that Advait?
Yes, that's me.
Yeah. So Advait, you're right on most of the aspects. Only thing which we're seeing as a problem is, and someone has already pointed out in the discussion as well, it's Kitna. Let me know if I'm taking your name correctly. It is UDP is usually considered for okay, not that broadcasting basically. So there was one second. There was one chat regarding broadcasting. Manish, yeah. So Manish mentioned UDP is used mostly for broadcasting, which is correct. And with UDP, we might lose data. Can we afford that? Let's say someone right swipe me and data is lost. Correctness or latency is not there. Let's say data is lost. How do we want to, are we fine with that?
Oh, that would be an issue. We want the database to update our preferences accurately.
Yeah, what a loss that would be. No, he might miss potential date. Yeah. Right. So we don't want to lose the data, right? Basically, this is something we are fine. We don't want to lose data, but still we want to have a efficient communication. Then what are the options? Are people suggesting TCP communication for each of the swipes? Is
Maybe
that
left swipe can be UDP and right swipe can be TCP.
What a way to design the system.
You might accidentally left swipe someone and we'll be happy that that profile came back later if it got missed.
Yeah, Manish is asking, is there any option than TCP and UDP? Yes, Manish, there is. There are a couple of options, but even with TCP and UDP, we are able to get most of the network bandwidth. Okay, so let me present to you two of the options that come to my mind, and one of these option is implemented by Tinder, Another option is implemented by Indian dating application known as Hinge. I'm not sure if I'm taking the pronunciation correctly, but yeah. So option 1, okay, let me write it in the NFR basically. So option 1 is based on out of WebSocket. WebSocket is something, it is built on top of HTTPS only, HTTP or HTTPS only, but unlike TCP, it makes your network call open. Whatever request you are sending, after getting the response from the server, it does not close the network, it does not close the network communication. It keeps that open so that further communication can still go in procedure. Let's say I left swipe profile 1, left swipe profile 2 and right swipe profile 3. This communication after left swiping profile 1, had it been normal TCP call, I know there are some advances in HTTP 2, HTTP 3, HTTP 2, where we allow to keep network communication open for some time, but usually with whatever development the backends are built or the traditional systems have built, they try to close the network communication once the server have returned to the responses. So WebSocket is something that helps us to make sure that network is not closed even after server sending back the response. So this is option 1, where we'll provide the quick and where we'll give the ability to communicate between client and server at as efficiently as possible. And second thing, we do not close the communication between client and server, so that whatever communication is going on between these two entities, it will use the same bandwidth, network bandwidth, which is they were using for the first call. So this is option 1. For option 2, let me take a question after discussing both of the option. Based out of pagination effort, pagination / bulk effort. So by pagination or bulk effort, what do we mean? So let's say I am swiping through Tinders, and let's say I do left swipe for profile 1, profile 2, right swipe for profile 3, left swipe. So these are my 5 swipes, all in all interaction with backend, and I send all this data in single HTTP request. I do not send HTTP request, TCP HTTP request for each of the activity, but I wait for some time, and after profile gets sufficient swipes either left or right, we do the pagination, where we send array of actions. Let's say for profile 1 I do left swipe, for profile 2 left swipe, profile 3 right swipe, and based on these bulk efforts we send the information. So these two are options available to us. Both of them are used in the production and both of them are correct. So I would take a pause here and see if there are any questions on these. Yes, TCP keep alive is something which is used, but unfortunately most of the backend servers that are built, or instead of backend servers I would rephrase it as load balancers, all of them do not support the keep alive option. Or if you want to keep alive network communication between these two, we have to make sure that certain settings are enabled for client as well and for the load balancer as well, so that the communication will be involved. What if application crashes before HTTP request was made in part 2? There is something in known as there is a local database for each of the device. So whatever activity we do, there is a write ahead log implemented in each of the device, whether let it be Android or iOS. We keep that in a way so that once everything is fine, application crashing is handled, we would pass the information to backend. There will be some lag, but we would not lose the information. Yes, definitely. If we are committing the choices locally, uh, will it hit app memory? It is going always going to be there. You for if app crashes and for we are doing bulk update for some time. Let's say for for each 10 swipes, I am doing the bulk update API call. Then for these 10 swipes, you will store that information locally, and once the backend call is complete, we will remove the locally stored data. It can be based on immediate effort, or it can be run on a hourly basis or per day basis as a nightly job. All of the options are available with us based out of how you are active on the application. Why would you choose WebSocket over regular single HTTP calls? Wouldn't using single WebSocket for swiping instead of regular make it expensive, considering the connecting is continuously open? Kevin, that's fine, right? Because we want to get the swipe based out of swiping left and right, you are going to get the next recommendation from your previous choice. So it is not only that your front end is communicating to backend is also continuously sending you the data. So WebSocket still makes sense because we want to get data from the both direction. For the bulk update, recommendation similar to bulk update of swipes, will get bulk recommendation. You will get 10 of the profiles in one go. After you exhaust to the list, we'll do next recommendation call and we'll get next 10 profiles. Awesome. There were such a good questions. Okay, Vignesh is saying WebSocket will raise concurrency issue. Vignesh, let's take it as a question. Can you unmute yourself and mention why would it raise concurrency question? Okay, cool. If you are comfortable, please use the chat as well. Okay, cool. So these are the non-functional requirements we want to fix in. I guess we're already over an hour, so I would take a snapshot of this and consider it as final functional and non-functional requirements. Okay, and we'll jump into design aspect. In the design aspect, let's see what are the required APIs we're going to use. We'll go through this real quick because they are really straightforward and beginner friendly. So we will need API for profile creation. We would need API for updating the dating preference, or let's say I want to update my hobby, I want to change my location, or my location changes and application determines it through background thread. We would be able to get that and update the dating preference. Getting recommendation is something where we need the API, and swipe is something where we need the API. Now, this is the first API we are going to consider: profile creation or dating preference updation. So it will look like /post API /API/v1/profile, and the content of the body of API will look like name, location, other profile related metadata, age, interest in images. So images is something we want to store it in object storage. We do not want to have images stored in databases locally in any way, because images is something where we do not directly query on. We want to keep it at distributed file storage. Some example would be AWS S3, Google Objects. There is service provided by Azure as well. Each of the cloud providers do provide their own service to update the metadata, static data such as images, videos, GIFs, etc. Then about me, there is some blurb about, hey, this is me being me, this is my interest and something like that. I'm software engineer, yeah. And then there is hobby like swimming, coding, chilling, etc. And for this dating preference, we'd get 200 okay as once the request is successful. Then there is swipe. We either rely on WebSocket or we rely on bulk update. I'm taking this example by considering we're relying on the WebSocket similar to what Tinder does. So what we'll have post API slash v1 slash swipe, and then we'll have user, which is my user ID, user swiped, which is to which user profile I have swiped to, and then swipe type, whether it is left swipe or right swipe. One very minor thing I would like to highlight here. Here I considered the swipe type. I did not consider is left swipe or is right swipe, the boolean parameter. The reason being, boolean would have always two values, true or false. Instead, we rely on enums so that it will have multiple values. Let's say in the future, let's say Tinder wants to come up with down swipe. Who knows? So for that, we would have need to change. We need to add another, another key in the request parameter only. If we want to add new key, we'd have to update all the DAO. DAO is basically data access layer, all the DTO, database translation layer, and the actual database. So we don't want to, for a single update, we don't want to have updates at multiple places. Instead, we want to keep it scalable and fluffy enough so that whenever new features comes in, we would be able to accommodate that. So here we would define the swipe type as left. If new swipe type comes in, I would say right, down, top, whatever, from middle, whatever comes in. So this is very small thing I would like to keep you highlighted on. So this is something you have, you need to take daily choices on this. This is something that comes to your day-to-day activities as well. And then there is recommendation, similar to swipe API. Either we rely on WebSocket or we rely on bulk API. For whatever swipe and recommendation we are seeing, if we had been relying on bulk option, we would have seen the array of such objects. So instead of seeing single object here, we would have seen array and one more object similar to this. Not one, whatever number you have decided previously. Something like this. This would have been the case if we had taken bulk update approach or bulk API consideration. Same for the recommendation. So instead of getting one recommendation, we'd get array of profiles to which we want to see through. On the location information, let's spend some time. Okay, let me take it to slideshow. Okay, before that, let me check chat if there are any questions. Super like, super swipe, that's recording too. Okay, we have WebSocket. What do we do after connection over WebSocket is lost? Usually, this is the concern for WebSockets. WebSockets are not that trivial to, we can say scale. They would need some additional information. They would need some sort of logic so that the communication is sticky enough. So there are some challenges comes in picture, but these are solved problems and a lot of companies have resolved these issues. So it's not really a problem if it is solved problem, like as they say. So we don't have to, we can consider it still as a proper solution. Is there any interval when requests are fetched in bulk if we use bulk efforts? Yeah, okay, cool. Location information, yeah. So Earth is sphere and we want to take location, distance between point A and point B. It is never going to be accurate information because we are projecting it on a 2D surface. So if we want to see, people based around me in say 50 kilometer radius, there are some solved solutions for this. Geohashing is one thing, geocell also known as this, where what we do, we try to divide the 2D aspect of Earth into equal square. So let me take to the drawing board and let's say, this is the blank Earth and I would consider this as a single region. Let's say I name it as 1. This is single position around which I want to see recommendation for the people. Now let's say I understand that this is big region. I don't want to keep it as single region. I want to divide it further. Now how I can do that? What I'll do, I'll just create a square. There is line. Okay. What I'll do, I'll just create a square for this, and then I'll consider that, hey, these are the 4 regions. Instead of 1 region, let's consider 4 regions, and from that 4 region, let's try to find the matches. So earlier entire earth was identified with number, let's say 0 or 1. Now from 1, what we'll do, we'll try to do 1 1, let's say 1 0, let's say 0 1, and 0 0. This is how we would like to divide it further. Now let's say this single cell here as well is too big for me. The recommendations are coming too big. How would I do? I would again do recursive operation on this and divide this cell further. Now how would I call each of this cell? Now let's say instead of it being called as 0 1, I would append a suffix and say it 0 1 1. Sorry, it is prefix is 0. Here prefix is 1, 0 1 1, 0 1.
Add 2 digits, not 1.
Yeah, okay, my bad. 0 0, because we are dividing it into 4. 0 0, 1 0, 1 1. Okay, so that's how I would divide it further. Now let's say again this is big square. How would I do it? I would again divide this square into further 4 part, and that's how I try to divide the earth on 2D plane at as limit as possible, so that each of this square would represent me around 50 kilometers of side. I'm not saying radius because this is square. I'm saying whatever surface area captured within this square is going to be around 50 kilometers. If it is going to be 50 kilometers, then from center I would get 25. On diagonal I may see some additional distance. It is not going to be 50, it is going to be 50 plus x. Same for the other diagonals as well. So from center to top, center to bottom, it is going to be accurate, but overall diagram there will be some approximation considered in this case. Now this is how usually we try to solve problem in geolocation. Okay, the problem comes in when user stays at the latitude and there are, okay, before taking a step back, we have divided this earth sphere into on 2D projection. From the 2D projection we have divided into cells. From there, what we are trying to achieve is we want to take user location in latitude and longitude, and from that latitude and longitude we want to get this cell in which the specific user has been located. With four digits we'll get to see this decision, this square with let's say area of, not area, with the side of, let's say 10,000 kilometers. I'm not sure how much it is, but let's take an example, 10,000. Then we'll divide it further. It will go to 5,000, let's say 3,000, 2,000, till 7 digit. We can go and assume that, you know, in the 7 digit we are going to get the radius of, let's say 2-3 kilometers. So again, taking a step back, we want to make it around 50 kilometers of radius or 25 kilometers of radius. So we'll fix a digit for each of this cell and identify that, hey, you know, with the 5 digits or with the 6 digits, we're able to get the actual cell where the user is located, and the cell in which user is located has the surface area, has the side, not surface area, has the side around 50 kilometers. It could be 49, it could be 51. There will be some plus minus x percentage, but that's the approximation. So with this, what we are going to see, let's say user is located here. I would just get the cell ID and I'll try to find profiles within this cell ID. If that's not the case, for the edge case like this, let's say user is located at this really tiny point. Okay, if say user is here, I would like to see recommendation from this cell as well, this cell as well, this cell as well, this as well, right? So in that case, we extend our algorithm to surrounding cells. It's a solved problem where if we have the cell ID of one cell, it is easy to get cell IDs of surrounding cells as well. So from that, we'll be able to get the cell IDs, and we'll able to query the specific location and figure out the recommended candidates for the profile. And further, we'll filter down on hobby, gender, age, etc. So this is how usually location based information is preserved. There are other ways as well, where quad tree comes into picture. Quad tree is usually used where there is movement between the location aspect. So usually in Uber's design, right, car will always move from cell A to cell B. It is not going to be a constant for that cell. Usually in such use cases, quad tree is used, where we do the same cell division, but instead of relying on same area, we rely on number of users or density in that specific cell, and that's how we do the quad tree design. There is 2D distance between lat and longitude. There like Euclidean formula, x2 minus x1 square plus y2 minus y1 square. Simple 2D distance between latitude longitude of two users, that would also work. City based storing is something which is very trivial. Let's say I'm based out of Bangalore, just give me profiles from Bangalore. Just do not worry about the cell and everything, latitude longitude. Just take my latitude longitude, get the mapping of city, and just show me the recommendations from city. Obviously these are kind of trade-offs we deal with, simplicity versus how much accurate we want our design to be. So this is something location based information I wanted to discuss with you. Now let's jump into whiteboard and do some real design components. Okay, I'll scroll down here. Okay, before that, are there any questions? Is there any intro? Okay, cool. Okay, cool. We have around 15-20 minutes. Lisha, is it fine if we get extend over 5-10 minutes?
Yes, Rishikesh, fine with me if everybody's fine.
Okay, cool. I hope everybody is enjoying, and we would really get deep into how this design would look like. So we usually start with the why is it looking like this? So what we'll do, okay, so usually we start with the API gateway. Okay, so API gateway is something which is external user facing and decides on the user type. It also does a couple of more things such as authentication, authorization. We do not want to look into login aspect of it. Let's say we rely on OAuth provided by Facebook, provided by Google, and we want to use authentication token from these external login provider entities and just run the minimal viable product. So we have the API gateway. Now let's see what are the services come into picture from our requirement gathering phase. First thing is obviously profile. Profile is something that is very basic thing. Then we have swipes. Then we have matches. I'll say profile service, swipes, capturing service, and then we have the matches service. There will be internal location service which either use Google's S2 library that gives latitude and longitude versus actual cell the user is in from the geohash. It is on Google's S2 library. Let's say this location service is wrapper on top of it. Okay, and then what other services do we need? We need recommendation service, which is really important. Okay. There will be common analytics service. Okay, analytics service just to monitor if things are correct in the system, and just to provide user the notification aspect, like, hey, there is a right swipe for you, or if some user has right swiped you or there is a match, you should get a notification that, hey, this is something where we would like your attention to. Let's go to profile service. Very, very simple, very straightforward service, where we would store user data. Okay, so let's say we store the user data. We jump into database type and schema based on how time permits us. Okay, so user data is something we rely on. We earlier discussed that, we don't want to rely on database for the actual image storage. Instead, we would use something like AWS S3 or something like object storage, irrespective of cloud provider, that, hey, this is something where we would actually store the images of the user. So request will come to profile service saying that, hey, I want to create a profile, or I want to update the profile, update my search preference. It will store the user data. It will also update the images if there is any in the request. That's it. That's the entire purpose of profile service. We want to take the profile service data, user data, and somehow connect with recommendation service. We'll see how we do that. Okay, but just keep this point in mind. The purpose of user data is two. If I open my account and say that, hey, I want to add this hobby, or I want to remove this hobby, I'll be able to do that. And internally, this profile service should be able, profile service, whatever data this profile service handles, this data needs to be somehow present for the recommendation service, so that it will get the correct recommendation for you. Then we have swipe capture service. Let's see how it looks like. We rely, right now we are considering we are going to use the WebSockets. So whatever swipes come through system, we want to store it in the database, saying that, hey, this is the swipes data. Anyone would like to discuss about what would be components of swipes data? What information do we need to store when we're considering storage of the swipes? Anyone? Yes, Ayush, you are right. We should use cache. We'll see how we reach to that version of this, MVP product, where we start using start using caching, even CDN as well, so that images load easily or without in near real time. Is there algorithm or different database or different table in same table? Is this algorithm altogether a different database? Okay, Nikhil. So usually whenever we consider microservices, we consider independent databases, so that scaling of each of the component is as straightforward as possible. Okay. So in SwipesDB, okay, no, since no one is answering to this aspect, what I'll just say how SwipesDB looks like. So we will have user 1 who did the swipe, user 2 to whom the swipe is to, or user 1 and user 2 based on the alphabetical order of the name. So let's say user 1 is ABC and user 2 is BCD. I'll tell you why we consider that, and then okay, in front of user 1, in front of user 2, and then we have the is liked by user 1 is swiped right by user 1, and similarly is swiped right by user 2. So this is the schema we would like to consider for the swipe capture service. Let's say I do a left swipe, say I am ABC, for BCD I do the left swipe. The swipes capture DB will store that hey, for ABC BCD is swiped right by user 1 is going to be false because I did left swipe, and this value will be null or empty or placeholder value. For right swipe I'll say this value set as true. For right swipe by user 2, if BCD likes my profile and he or she also does the right swipe, I would get both of these values as true. Once these values are true, we would like to invoke the match service. Have we known the concept known as CDC or change data capture or trigger in database? Anyone knows about this concepts? Swipes DB is NoSQL? No. Okay, no. We're getting no. Okay, cool. So basically CDC, that is change data capture or trigger, are kind of mechanisms available to specific database table such that whenever a new entry comes in or any existing key of the database, any existing value of the database changes, this function will be triggered. So this is what known as CDC, change data capture or trigger mechanism. Streaming is something that is again feasible here, but usually for communication bits, for such communication, CDC or triggering mechanism are just fine. If we're still dealing with millions of requests per second, we would like to move this solution to streaming, but to begin with, CDC or trigger is just fine. So we'll get to the swipes. Swipes will say that once if two of these values is swiped right by user 1 and is swiped right by user 2, if both of these values are true, we will notify the matching service saying that hey, there is a match, send them the notification. So matching service will do some validations saying that hey, whether the swipes were recent, are the swipes are still in the same 50 kilometers radius. It could be the case that I did the right swipe and I moved to USA day after tomorrow, and then user 2 did the right swipe to me. There needs to be some validation on top of whatever swipes are present with us. That will be taken care by matching service, and it will if all the matches are correct, then the matches service will send out the notification saying that hey, there is a match, you need to notify. If there is no match but there is still swipe right by user 1, user 2 should be notified. If user 2 is swiped right to user 1, user 1 should be notified. So in a way, this value somehow needs to reach to notification in order to make sure that user knows, the end user aware about the whatever changes we are doing, whatever updates are there. So let's say there is application here. Okay, and this will go back to the user for his or her notification. Cool. So till this point we have good amount of information where how swipes will work, how notification will. Okay, now again think similar to profile service, our swipes needs to somehow populate till recommendation service. Recommendation service needs to know what kind of profiles I did right swipe to, what kind of profiles I did left swipe to, and based on that recommendation service needs to update its recommendation. Okay, so whatever information we store here needs to pass through, needs to be streamed. Okay, by streaming I mean we have some asynchronous processing on top of whatever changes we have. So let's say whatever events are coming through, they are captured in a message base, in a message queue basically. So if I do font M or L, okay, and we write it as message queue. There are multiple message queues readily available to us. Log-based message queues include Kafka, then there is RabbitMQ, SQS is something, Redis also provides in-memory message queues. Based on what are the latency requirements for us, this message queue will vary. Obviously, in-memory message queues are going to be expensive, log-based message queues are going to be cheap to use. Now, whatever information this message queue will have, it will be processed by a worker thread, or let's say some Elasticsearch service, Elasticsearch worker service. Why Elasticsearch? Elasticsearch is something, anyone knows about Elasticsearch before jumping into why Elasticsearch? Anyone knows about Elasticsearch? Okay, log-based, cheap to use mean. So log-based messaging queue is something that relies on files instead of keeping everything in memory. So log-based message queues such as Kafka, such as SQS, it is something that are cheaper than the cost of Redis, where Redis also provides messaging queue along with the caching service. CDC is event call, webhook call to matches service. CDC is a plain network call. We do not have to worry about if it is going to be a webhook call or matches service. It's a plain trigger based mechanism where we execute specific function, and through that function we push the data to some replication or to some other data store. Elastic service good in query when data is huge. Not really. I mean to say Elasticsearch worker, not Elastic work. So Elasticsearch is something that works really great with textual data. So whatever text based searching we have, let's say hobbies, let's say my description, these kind of data works really great with Elasticsearch. So Elasticsearch is natural choice. It is built on top of Lucene. Okay, Lucene is open source searching algorithm. If you have more interest in Elasticsearch, I would highly recommend you to check Lucene code base. It's really simple, written in C++, partly in Java. It's really simple to see how inverted index looks like and how Elasticsearch efficiently searches through text-based data. So whatever data we go through, the user data, swipes data, we will capture that from streaming service to this Elasticsearch worker. It will do some processing and it will store the data to Elasticsearch based shards. So shards are something we want to have on the Elasticsearch based out of location. Why so? Let's say I want to see recommendation based out of Bangalore. I am not interested in the data where user is located in New York or user is located in Seattle. I do not want to care about that data. I want my data on which I can query as small as possible. So Elasticsearch worker will push the data in Elasticsearch shards, where shards are, by shards we mean small table. Let's say we have huge table. We want to divide the table based out of cell. So let's say cell 1's data reside on DB shard 1. Cells 2 data sits on DB shard 2. Something of that sort. Based on shard, we want to keep data of the user to that specific cell. And this is how we do the sharding on top of location. It is also known as geo-based shard. It is readily provided by Elasticsearch. This service is again provided by MongoDB, Redis, and most of the databases as well. In terms of SQL, in terms of SQL, PostgreSQL does really readily provide the location-based search and location-based sharding ability as well. So This is something we want to use Elasticsearch property, so that whatever data I would search in the location where the user is residing in. If I'm in the cell 21 and cell 21 belongs to Bellandur area of Bangalore, I would like to see cells around the cell 21, let's say cell 20, cell 19, cell 22, cell 23, and from those cells only I would like to capture the recommendation for the specific user. Now Elasticsearch worker service will will update the data in this recommendation database, recommendation Elasticsearch source. Recommendation service can either directly query this Elasticsearch charts, or it can do pre-computation as well. It does not need to be have processing when the request comes. Let's say I am a user who is active user on Tinder, and I see Tinder profile during 8 to 9 in the night. If that is the case, if this is well-known user activity, instead of we querying this data every single time once I log in, why not just pre-compute the data and store it in the cache? Okay, the caching point that came before we started the discussion, right? This is where the caching comes into picture. We do not want to do the runtime query. Instead, we can store it, and from that storage we'll do the further queries in order to make sure that we have the data with near real time. There is no latency involved by querying to Elasticsearch. We have the recommendation ready for the user, and through that recommendation we'll be able to give the recommendations, top, let's say 100 recommendations, or pre-computed 200 recommendations to the user. And then there is analytics service who is going to have look up on all the metrics, all the databases, all the latencies, all the success versus failures parts, etc. So this is how in general on a very high level Tinder system design would look like. I would have loved to go in deep about how swipe capture service does, what notification service does, because notification is big service in itself, where we need to have further queuing mechanism. If we want to send notification to say Android mobile, we want to send notification to iOS phone, there is multiple ways to handle those notifications. Firebase does readily provide notification aspect to us. So these are kind of things we would have loved to go deep further into, but I guess we're already over time, and I would like to take a step back here and take your questions from here. Okay, I would consider this as something MVP design for our product, and we would like to stop here at the early phase. So yeah, I would like to take questions from here, or how pre-compute works here. Are we adding some schedulers? Yes, exactly, Ayush. We would like to have some nightly job, if you are aware, or cron job, if that is the general information, right? So this night cron job or something we can run and figure out what's the user activity state, and from that we can compute the pre-recommendations feed for the user. Awesome. Can we discuss a bit on data modeling? Yeah, we'll definitely discuss the data modeling. Why did we use queues here? Vedant, I'll come back to this question after answering Swastik's question, okay? Because your question involves some more drawing and other aspects, okay? Why did we use queues here, okay? Now see, we usually use a queue whenever we want to have asynchronous communication, okay? So whenever user data changes, or whenever swipes changes, do we immediately need to update the recommendations? Now let's say we are getting very high volume of swipes during the specific, let's say 8:30 to 9 is very active user time, and I'm getting swipes in terms of millions of requests per minute. Do I need to update or scale up my recommendation just for this half an hour? No, right? Instead, I can let the data reside in the message queue, and I will use whatever data has been captured from user data and swipes data, compute through it, and then push it to the Elasticsearch. That will just update the recommendation a little later. Something we considered about cap theorem, right? So if it is really consistent that we want, or it is something we are fine with some delay, 1 minute delay, 10-minute delay, 1 hour of delay, that's still fine. So that's why we usually use the message queue, so that independent component can be scaled up, scaled down easily. Will we discuss scalability, load balancing as well? We can discuss that as well. Yeah. Before that, I would like to take a step back with Vedant's question. Okay, that is something which we really like to discuss. Vedant's question was what the data's modeling looks like for each of the DB. We have user. I guess everyone would be easily able to model the user data, some metadata of okay, let me not use this space. User data. So user data would be plain name, important aspect would be age, search preference, then we have location cell, right? Location cell is how we get by querying to location service. Basically we have this location service wrapper on Google S2 library. So location cell, in which cell user is residing in, and then we have some about me section, right? So this is really, and there will be image URLs, right? So at max we would allow 5 your images present by the user, so we'll provide the image URL as an array of links. User data, we can, since this is not going to have require any joins, or it does not need any aspect with respect to querying really complicated data, we can simply throw this data into key value pair, something either AWS DynamoDB, even MongoDB document, which is a document based data store, having index on underscore ID field would easily work here and would be able to do the job. So I do not like to go into SQL here because we are not querying on specific field. If account preference update or anything comes in, I'm just going to update this field, and I do not have to worry about having complicated joins, having complicated queries. So that is how user looks like. We have swipes DB already here. Okay, I'll just take it outside and call it as swipes. Okay, then we have matches service. Matches service does not have its own data. It is using the swipes data and these two attributes in order to make sure the swipes are valid, and then it will pass it to the notification. Notification service is not keeping its own database. We can use external services to use the notification, or we can have in-house notification on top of cloud providers that we have. So example, AWS provides simple email service, simple messaging service, simple notification service. So these kind of services we can readily use. Definitely there is equivalent in Google Cloud and Azure Cloud as well. Recommendation service, Elasticsearch worker. So this data in the Elasticsearch is going to be something like this. Okay, this is really interesting thing, and this is last piece of our data modeling puzzle. Okay, recommendation will have for which recommendation, for which user this recommendation is. So let's say user 1, this is the recommendation. What are the created at? So something we definitely would like to have when this recommendation is updated for this user. Okay, what is the recommendation match? So let's say we give match from 1 to 10 and how closely this user is matched to U1, so that we can rank it accordingly. So score in the range of 1 to 10, and then we have the recommended user ID. Okay, and from there we'll get all the information such as name, age, and the image URLs and about me section, which we can push to the feed service of the Tinder. So this is how our normal recommendation data modeling would look like. I hope this answers most of the questions. Okay, cool. I don't see further questions. Will we discuss scalability, load balancing options as well? We can discuss scalability. Whatever components we have considered are horizontally scalable in a way that we are not specifically relying on native boxes or native clouds, native non-cloud solutions. So they are all horizontally scalable, and load balancing option we can consider for each of the services. Okay, assume this, right? So whenever I draw a single box, it is not a single service. Multiple instances of this service are going to be in background. So there will be multiple profile services running accordingly, multiple swipe capturing service, matches service, recommendation service, and analytics. They are not single point of failure. Yeah. Yeah, I think that's there. I think most of the questions are answered. Cool. Let me, all microservices is hosted on different servers. Nikhil, we would like, not necessary it is needed. We can consider containerization as well in same container. With the Docker containerization, we can host multiple services as well without affecting each of them. Okay, so even though they reside on the single component, they can still be scaled up or scaled down independently. We use load balancers for better performance. Not really, right? We use load balancers to make sure whatever multiple instances are there in the services, they are getting each request basically. So let's say there are 2 servers and 10 requests comes in, and there are no such requests. I would like to give 5 requests to each of the server. Yeah, kind of equal traffic. Equal traffic if both the servers are equally powerful. If one server is less powerful, other is more powerful, we would like to have weighted average as well. While implementing design system, we use different programming language for different components. We can definitely use that. Different programming language for different services is really something that is advantage of microservices, and each team can work independently without mitigating any other team. Yeah, I guess, yeah, we answered most of the questions. Lisha, you want to take over?